Welcome back. This is the second lesson recording for IM1, January 20, 2021. So we just finished Desmos card number 1 to 7. Now let's just summarize the key things that we should have noticed. Well, these are the Desmos cards that you came across. Cell division is a geometric increase. So in your biology class, when you learned about mitosis and meiosis, cell division is an example of a geometric sequence where it is multiplying by 2. So they're each multiplying by 2. That's how the cells divide, right? So in this case, you're trying to find the missing number. How would you do that? Well, the first term is 2, and we use the term notation a sub 1, and that's a sub 2 to say the second value, the value of the second term, and a sub 3, fourth term, fifth, and then that's the 10th term. Okay, so that's how we figured it out. Okay, so then when you look at what Jada did, she just multiplied the previous number by 2. So the previous number was 2, and then multiply that by 2. The previous number was 2 times 2, then multiply that by another 2. The previous number was 2 times 2 times 2, right here, and then multiply that by another 2. But what Noah did was summarized what Jada did in a much more efficient exponent notation. So 2 is same as 2 to the power of 1. 2 times 2 is 2 being multiplied to itself twice, so 2 to the power of 2. 2 times 2 times 2 is 2 being multiplied to itself 3 times, so 2 times 2 times 2 is 2 to the power of 3, and then 2 to the power of 4. So then, repeated multiplication can be represented as exponents. That's the conclusion that you should be making. Repeated multiplication can be written as exponents. Okay, now you're going to go on to card number 8 to 14, where you're going to be practicing graph and table on new geometric sequence. Okay, so you have a different geometric sequence. Now this time we're told that it's a geometric sequence with a sub 1 being 0.25. What does that mean, a sub 1? That means the value of the first term is 0.25. So when n is equal to 1, the value here is 0.25. Okay? Oops, I meant to write 0. 0.25. And the common ratio R is 3. That means I am going to multiply the previous number by 3. So if I multiply 0.25 by 3, what do I get? I get 0.75. Okay, now what do I get if I multiply the previous number by 0.75? Oh, I'm sorry, the previous number, which is 0.75 by 3. Okay, you can use the calculator. You get 2.25. And what do I get if I multiply that number by 3? I would get 6.75. And what do I get if I multiply that number by 3? I would get 20.25. And what do I get if I multiply that number by 3? I would get 60.75. And then multiply that by another 3. I would get 182.25. Okay, so I can check my answers, and it says awesome. Great. So then you are supposed to graph the table that we've just created 1 comma 0.25. 1 comma 0.25 is going to be really close to the x-axis, but not quite. Okay, it's a very small number. When n is equal to 2, 0.75, it's less than 1, so it's again going to be very close to 1. Okay, this time 2.25, so maybe it's about halfway, like so. And then 6.75, maybe 6 and 7. Okay, and then 20.25 means that's really close to 20, and then 182, no, 60.75. 60.75 will be just over 60. Okay, so though this is the graph. Okay, here is the graph of the geometric sequence. Go to the next card when you are ready. This is what we had and what you should have. Describe graph of geometric sequence. Okay, so here are the two graphs of the two geometric sequence we worked on. What do you see as being common? Okay, is it a straight line like arithmetic sequence? No, it's not a straight line. They are curved line, and it seems to be increasing. And this is actually an example of exponential graph. And hopefully we'll cover exponential functions later on. Okay, now sort into two decks, arithmetic sequences versus geometric sequence graph. Okay, so I need to sort them now. So geometric, let's put geometric over here, and let's put arithmetic over here. Oops. Okay, so arithmetic sequence is always going to have a straight line when I try to follow the train, while as geometric is going to have a curved line like this. This one's going to be a straight line. So whenever you see a trend of a straight line, that's going to be arithmetic because we are adding a same common difference, while as when you see an arithmetic sequence, it's going to be curved line like this. Okay, it could actually be going down depending on whether the common ratio, the number that you're multiplying by, is less than 1. If it's less than 1, it's going to get smaller. Okay, so then let's move on. For the geometric sequence graph, what is the common ratio? So looking at this, how would I figure it out? Well, if I click on any of the points, I am going to get the number values. So if I click on any two subsequent points, okay, so when n is equal to 4 and n is equal to 5, you get the y value, or the a sub n value. Okay, so this will be a sub n, a sub 4, this will be a sub 5, or the fifth term value, fourth term value. How would I figure out the common ratio? Well, I know that it's going to be between 3,906.25, 3,096.25, and then okay, 3,996.25, that's, and then previous one is 1562.5. 1562.5. Okay, I just need to pick two points, and they have to be consecutive. That means one after another. I could have picked a sub 1 and a sub 2 and divided a sub 2 value by a sub 1 value, or like that too. But then, okay, I think I made a mistake somewhere. Okay, it's actually 3,906. Okay, and then it comes out to be 2.5. And I know this is true because 250 divided by 100 is going to be 2.5 as well. Okay, so that's my common ratio. And then you get to just wait for your classmate by watching this. Okay, this is pretty cool. A Jenga move. What do we notice about geometric sequence graphs? They are going to be curved, and it's not going to be a straight line like the arithmetic sequence. And this tells me that r is equal to 3 because every time when the x value increased by 1, the y value is multiplied by 3. Okay, and what is this? R is equal to 2. It's being doubled. So that means whatever this value is, however tall this is, the height of this is 3 times as much. Okay, 3. So if I have this length multiplied by 3, I will get this. While as this length, the previous number had this length, or the value, the a sub 5 had the value of this little, like 32, and this is twice as much because r is 2. That means it's being doubled. Okay, finding common ratio from graph. What you need to do is get 2 points, 1562.5 times what is equal to 3906.25. So get 2 points, and you're dealing with the y value because that's what the term value is. So what does that question mark have to be? Okay, so you're going to, since 1562.5 is being multiplied to that question number, to get rid of this, just to get the question mark, you're going to divide both sides by 1562.5, and which leaves us with 2.5. That means the common ratio r is 2.5. So now you're going to go on to card number 15 to 18, and you're going to be looking at the equation of geometric sequence. Okay, so remember how Jada and Noah represented the term values? They represented slightly different. Okay, show what Jada and Noah would write here. Figure out the value of question mark, question mark, and question mark. Then complete the rest of the table. Okay, the first thing is, alright, what is the first line going to be? The first line is just by itself, so this is going to be 0.25. Okay, not 0.25, 0.25. Okay, now whatever the previous number was, you multiply that by 0.25. So that question mark is going to be 0.25. Okay, multiplied by 3, because whatever the previous number was, I multiplied that by 3. The previous number here, now to consider what the first number is. Okay, the question mark is still going to be the same. It's going to be 0.25. So it's the whatever the number that you started off with. Okay, when a sub 1, what is the first term value? It's whatever the number. So the question mark represents the first number. And so this is going to be 0.25 again. Okay, now we're being asked, what is question mark? Okay, what is this? Okay, we're multiplying. Okay, so let's just fill in the rest. Okay, so that means for this, I am going to copy this and then multiply that by another 3. And then for the next, I am going to copy this and multiply that by another 3. And so for this, I am going to be copying this and then multiplying that. I have 1, 2, 3, 3 times, so I need